Hello everyone, and welcome to Jam Academy. In this example, we have a graph that shows the force acting on a block along the x-axis. We have been asked to calculate the total work done on the block. This is quite an interesting problem that involves a force versus position graph. Now, it is worthwhile for you to remember that the work done on the particle is the area bounded by the force versus x graph. Let me say that again. The work done on the particle is equal to the area bounded by the force versus the x graph. Let me write that down. The work done is equal to the integral from xi to xf f dot dx. This is just equal to the area bounded by the force versus the x graph. Always keep this in mind. So what are we going to do? We're going to break down. My recommendation for you is to break down the graph into various segments. Now I'm going to use different colors so that it should be clear to you. And this is segment A. I'm going to call this segment B. This is C. That is D. And this is E. So I've broken down the graph into 1, 2, 3, 4, 5 segments. Now we will calculate the area of each segment. Now in each segment we either have a triangle or a rectangle. Now the area of a triangle is half base times the height. The area of a rectangle is length times width. And I believe that it's kind of easy for us to calculate. So the work done between x equal to 0 to x equal to 4, let me put it that way. This is going to be equal to the area bounded by that graph. So this is just 1/2. The base is 4 meters multiplied by the height, which is 300 newtons. So we will have here 600 Newton meters or 600 joules. Now, the work done WB, this is a rectangle. The area of a rectangle is just the length multiplied by the width. So we will have here the length here, this is 8 minus 4. So we will have here 4 meters multiplied by the height. This is 300 newtons. So we will have here 1200 joules. So WC, this is a rectangle. We have 1/2. The base is 2 meters because 10 minus 8 is 2 meters multiplied by 300 newtons. So this is just going to be equal to 300 joules. Similarly, we have WD, which is a triangle. This is 1/2. This is 10, 12. So that is 2 meters multiplied by negative 100. This is going to be equal to negative 100 joules. Notice that it is negative 100 joules because here the height is in the negative directions. You should not forget that. Now the next, we will have E. So WE, which is just a rectangle. So we will have here 15 minus 12 is 3 meters. Multiplied by negative 100 newtons. So we will have here negative 300 joules. So the total work done on the block will be equal to the sum of all the work done. This is A. So this is just going to be WA plus WB plus WC plus WD plus WE, which means that the total work done will be equal to 600 plus 1200. That will give us 1800. So 1800 plus 300, that will give us 2100. 2100 minus 100, that will give us 2000. 2000 minus 300, that will give us 1700 joules. So the total work done on the block is 1700 joules. Now this is quite a beautiful problem, and I will encourage you, for the purpose of the upcoming exam in this particular module, for you to review this particular problem, because obviously there will be a graph for you to calculate the total work done on the particle. Now, that being said, if you do not understand anything with regards to this problem, please ask in the discussion forum below. Thank you so much and have a wonderful day.